Hello, everybody. Hey, did you see that? Whoa, there it goes again. Did you see that? No, probably not. And the reason is because they're invisible. What am I talking about? I'm talking about radio waves, and they're passing through us and around us all day, every day. Welcome to the Epic Flight Academy and the Instrument Rating course. I'm Mike Thompson. I'll be your host. And I want to remind you, 3 keys to success in the course. Number 1, please be studying this content in Epic's online course. Number 2, viewing these videos. Hey, we're glad you're here. And number 3, you're going to want to review this content in detail with your flight instructor. So what about these radio waves? They're everywhere, and they're all different frequencies. We can't see them, but we sure do use them. We want to talk a little bit about some radio principles as we get you on your way to your instrument rating. Now, there are 3 types of radio waves, and you can see in our graphic here. We are talking about ground waves, and these have a frequency of 100 hertz to 1 megahertz. And you see that 1 megahertz is the capital letter M hertz. That capital letter M stands for million. Mega means a million. The second type are the sky waves. The sky waves are 1 to 30 megahertz. And the third type are what we refer to as space waves. These are 15 megahertz and above. Now, on the graphic, you can see these ground waves are the most common, and they're used for VHF navigation and communication. And we're going to talk about, and you're going to learn about the VOR, the NDB, the ILS, etc. Now, these waves are limited to line of sight, and they reflect off hard objects and cannot penetrate the ionosphere. So they typically have a shorter range. The second type you can see here, we call the sky wave. This is useful for HF communications over long distances. Why? Because this frequency band reflects off the ionosphere and back to Earth. And then the third type are space waves. These are much higher frequency and can penetrate the ionosphere. And you see, those are used for things such as GPS navigation and communication. So let's take a look at some of our radio navigation tools. And we're going to start with the NDB, otherwise known as the non-directional beacon. And it's called a non-directional beacon because it's a ground-based transmitter that radiates a signal in all directions. No particular direction, all directions. Now, review this with your flight instructor in the AIM Chapter 1, Section 1, Paragraph 2, 1-1-2. Review this with your flight instructor. You're going to find out that these systems are being used less and less. They're less and less common, and you're probably really only going to fly one in the simulator unless you get to some more remote parts of the U.S. or other continents around the world as well. The non-directional beacon is really 2 parts. That beacon is ground-based, and then in the graphic here, you can see what is airborne in your aircraft is called the ADF, or Automatic Direction Finder. Now, the aircraft that we fly at Epic do not have an ADF receiver, but we can use GPS to fly to and from an NDB instead. The next type of equipment we want to talk about is distance measuring equipment. Again, review it with your flight instructor in the AIM Chapter 1, Section 1. Now you're in Paragraph 7, 1-1-7. This is a ground-based navigation system in which distance, speed, and time can be determined. Now, these are often coupled with a VOR or an ILS system. Now, the way it works is you tune to that DME station and your receiver sends an interrogation signal to the station. The station receives it and sends it back. You can see that here in our graphic. Now, the DME does have some limitations and a couple of errors. Its limitation is line of sight, and it's reliable up to approximately 199 nautical miles. The most common error that we see with the DME is what we call a slant range error. And you can see in this picture, the distance of that slant range is actually different and slightly larger than the horizontal ground range distance. Now, this will really come into play if you take a look at this example from the AIM and you see an aircraft flying directly over the top of a DME. So the ground-based distance to that DME is actually 0, but the aircraft is going to see the DME indicate that it is 1.2 nautical miles from that DME equipment. Now, how can that be possible? I'm directly over the top of it at 0 nautical miles, but it says 1.2. Well, you can see in the picture, it's 1.2 miles vertically. And so you can see where the slant range causes a larger and larger error the closer you get to that DME. Well, thirdly, we have what we call the VOR. Now, the VORs are widely used and they're very effective, and we still fly them today, and we wonder, what does VOR stand for anyway? What it stands for is very high frequency, omnidirectional range, VOR. These are the primary ground-based navigation aid used in the National Airspace System and across the world. These nav aids have been used to develop the airway network here in the US. You can see an example of that. For example, on the low altitude chart, which we'll discuss in a later video, we see this solid black line and it says V4, Victor 4. That's a Victor airway. That's an airway between VORs. Now, these VORs have a frequency range of 108.0 to 117.95 VHF. VORs are identified by a 3-letter identifier and Morse code. Now, gradually over time, you'll see that GPS and RNAV are slowly replacing the VOR systems. So let's dig into this VOR in a little bit more depth. And remember, each VOR is aligned to magnetic north. It was aligned that way when it was built and installed. So you may come across a VOR that is no longer directly aligned to magnetic north because the magnetic pole has shifted. Now, each VOR has 360 radials. These radials extend in a line directly from the station. And as a pilot, you can select any of these radials by selecting an appropriate course on your nav system. So the radial indicates a line extending from the station. The course indicates the direction that you are going. Now you can see our aircraft here. The aircraft is heading north-northwest and crossing the 315-degree radial. So step one in any VOR navigation is to ask myself as a pilot, where am I? Where are you? And the way we do that is we center up a radial with a from indication. So if I was in this airplane and I centered up a radial with a from indication, it would be radial 315, and I would say, oh, I am on the 315-degree radial from this station. And you can see in our picture, I'm northwest of that station. So that's step one. I'm oriented to where I am. All right, step two is I ask myself, well, where do I want to go? And step three, I ask myself, well, how am I going to get there? So on that same graphic, if I said, well, I want it to be on the 360 radial, and I want to fly away from the station, I would select 360 with a from indication and center it up and fly away. If I wanted to track the 360-degree radial to the station, I find I'm still north of the station on 360, but if I wanted to go to the station, I would now fly south or 180 on the 360 radial. In our example here, we're showing an aircraft on the 090 radial, and if he's 090 from, he's flying east from the station on that radial. If this same airplane wanted to turn around and come to the station on the 090 radial, he would have to fly 270. So always fly the head of the needle and match the arrow with your direction of flight. Now, your flight instructor is going to review this in detail with you in the simulator and in the aircraft. Let's just go to this last slide and practice a couple. So here we show the red radials and scenario number one. You want to fly the 050 radial to the station. Well, what do you select? You would select the 050 radial. Do you see that? But to fly it inbound to the station, you would have to be flying a heading of 230. Let's look at example two. You want to fly the 340 radial from the station. Well, you would select the 340 radial and dial in a from indication, and you would be flying a heading of 340. And finally, example number three, you want to fly 230 to the station. What course would you select? Well, you would have the 230 radial, but to fly to the station, you would be flying 050. Now, I want you to practice these with your flight instructor. There are several examples in the online course that you can practice, and you can make up your own scenarios in the simulator. And of course, in the aircraft, you're going to fly the real thing. So, quick review of the VOR, folks. That's our introduction to radio navigation. Join us next time.